I'm Lynn Bondurant at NASA's Lewis Research Center in Cleveland, Ohio. This time our program is called Life on Three Planets Beyond Earth. It's one program in the series of 13 in which we look at how man has learned to travel in space and how he is seeking life forms not of this Earth. In our previous program, we looked into the topic of life elsewhere. Today, we will look at three planets beyond Earth, thought at one time or another to sustain life. To begin, we will show clips of NASA films that show pictures received from our Pioneer probes to Jupiter. We'll also see NASA's picture postcard and the Earth Sounds record that was launched on the Voyager probes beginning in August of 1977 in case of their eventual future contact with an alien race. Now let's examine Jupiter.
After the first stage of prettying up, Jupiter's first close-up portrait emerges. Late November 1973, 20 months after launch, Pioneer 10 closes in on Jupiter. Each hour brings the planet 20,000 miles closer. What lies below those inscrutable cloud tops? Could there be life in this maelstrom where pressures may reach 200,000 times Earth's? There are scientists who think that the answer might be yes, that deep in this raging atmosphere of ammonia, marsh gas, and helium, the self-replicating spark may have been struck. One believer is Dr. Carl Sagan of Cornell University.
Jupiter has an atmosphere rich in hydrogen and its compounds, the same kind of atmosphere that the Earth had at the time of the origin of life. So we think that the building blocks of life, at least earthly life, are being produced on Jupiter today, raining down from the skies like manna from heaven. And Jupiter may be a vast planetary laboratory in the chemistry of the origin of life that's been working for about 5 billion years. It's by no means out of the question that there are forms of life in the clouds of Jupiter. And indeed, if you viewed the solar system from afar, I think you could make an argument that life on Jupiter was more likely than life anywhere else, including on the Earth.
Dr. Sagan also provided for Pioneer the famous picture postcard to extraterrestrial life.
But in the remote contingency that there are interstellar spacefaring societies which might someday pick up this derelict no longer radioing, we thought we would put a message on it to indicate a little bit of where we are, when we are, and who we are. We think that the information on where we are and when we are, indicated in this part of the message by the configuration of certain cosmic objects called pulsars, will be completely obvious to any society capable of traveling between the stars. These two objects will be more mysterious because it is unlikely that there will be human beings anywhere else, even though there may be other creatures elsewhere. And the plaque has served a very useful purpose in making us think about what sort of impression we might wish to give to the cosmos.
In case the Voyagers encounter a cosmic neighbor along the way, these sounds of Earth, including the music of Bach, Beethoven, and Mozart, the sound of a whale, of rain, heartbeats, and laughter, have been permanently etched into the grooves of a special copper record, along with 115 photographs and diagrams depicting our civilization. One of these records was placed on each of the Voyager spacecraft before launch from the Kennedy Space Center. The messages were designed to give a picture of 20th century Earth and its inhabitants to possible extraterrestrial civilizations who might intercept the spacecraft millions of years from now.
Venus was also thought to be able to sustain life. On August 27, 1962, Mariner 2 was launched towards Venus. This was our first successful planetary probe. In the following clips from a mid-1960 NASA film, we will see early scientific opinions about life on Venus. We will also show the results of Mariner 2's flight.
Because of the thick clouds, it seemed logical to suppose Venus a wet world, young, hot, and covered with swamps. Result, it was imagined that only low forms of life exist there. Then, in this century, spectrographic examinations showed that if water exists on Venus, it is present only in trace amounts. The atmosphere, predominantly carbon dioxide and nitrogen. Conclusion, the clouds might be composed of fine dust. The surface could be an arid, windswept desert. Shortly before Mariner 1, Dr. Carl Sagan wrote a paper summarizing the information and theories then available. Many theories of the Venus environment have been suggested. However, new information eliminates at least some of these theories. Measurements with radio telescopes show that there is a region on Venus where temperatures are greater than 600 degrees Fahrenheit. It is just possible that the hot region exists at a high altitude in the ionosphere of Venus. The surface temperature could then be almost Earth-like, and life as we know it could exist there. However, it is more likely that the hot region is the surface, heated either by an enormous greenhouse effect or by wind friction. Therefore, if there is life on Venus, it is probably of a type that we cannot now imagine. February 26, 1963, the preliminary results. At the encounter altitude, Venus has neither a magnetic field nor a high-density electron ionosphere. Temperature at the top of the cloud, minus 60 degrees. The planet's surface, about 800 degrees. As Earthman knows it, there can be no life on Venus.
So we conclude that the possibility of life on Jupiter or Venus does not look too promising. Our other neighbor, planet Mars, however, has been thought to have conditions allowing life forms by both scientists and science fiction writers alike. Therefore, for the remainder of this program, we will closely scrutinize Mars. In the following clips, you will see simulations of the Martian surface, including craters, polar caps, channels, and layered terrain. We will also hear scientists' opinions of the possibility of life on Mars and what some of those life forms might be like. Experiments that would be done on the Viking lander are also explained. Let's watch the rest of the program.
Of all the other places that life might exist in the solar system, the chances appear greatest that life may have at some time existed on Mars. After traveling through space for nearly 1 year, a unique landing craft approaches Mars to soft land on a planet covered with dust. In the Martian dust, there may be biochemical evidences of life.
And then in 1975, 2 Viking spacecraft were launched, each of which was programmed to land a robot on the Martian surface. One of its principal objectives was to test for the presence or absence of living organisms. A communication system linked the spacecraft to the Mission Control and Computing Center in Pasadena, California. On June 19, 1976, the first Viking arrived in the vicinity of Mars after a year-long journey of more than 400 million miles. Once in orbit, its cameras were turned to a detailed examination of the landing area.
Parachute separation. Roger. Minus 105.3 G. 2,600 feet, 188 feet per second.
2,600 feet. 2,600 feet.
366 feet, 73 feet per second. ACS is close to vertical. Nav is green for touchdown. ACS is green, 1.5 degrees per second max, 22 Gs, 6 feet per second.
Touchdown, Win. Fantastic. 16 kilobits confirmed.
While the landers conducted experiments on the surface, the orbiters swinging around the planet measured variations in moisture and temperature and took high-resolution photographs of the Martian terrain. Over millions of years, the repeated flows of lava built the volcanic mountains of Mars. 12 are larger than any on Earth. The largest, Olympus Mons, rises 3 times higher than Mount Everest and is broad enough to cover the whole chain of volcanoes that form the Hawaiian Islands. The great gash that cuts through Mars' equatorial zone is Valles Marineris, a mighty canyon system that extends over an area more than 3,000 miles long and up to 400 miles wide, and drops 4 miles below the flat cratered surface of the plateau. Canyon walls are gullied, dissected by tributary canyons, or scarred by catastrophic landslides, leaving steep cliffs and great fractured surfaces. Extending for 30 miles on the canyon floor is a field of sand dunes, suggesting that some of the debris produced by the collapse of the canyon walls was removed by wind. Because of Mars' low atmospheric pressure and low temperatures, water can't exist in liquid form. It must either freeze or evaporate. But while there are no oceans or rivers on Mars, there is more water in total than anyone had expected. The residual polar cap in the north, which remains after the hottest part of the northern summer, is water ice mixed with dust. And the measurements of the seasonal behavior of water vapor over the planet suggest that there is a vast reservoir of ice beneath the surface, so that one can think of the residual polar cap as the tip of an iceberg protruding from a sea of rock. At lower latitudes, the water vapor condenses to form clouds that ride high in the atmosphere or swirl around the slopes of Martian volcanoes. And further south, in the canyons and valleys, there is frequently an ice haze seen to form and evaporate in the early hours of the morning as the sun warms the atmosphere.
There are old parts of Mars which are cratered by hunks of rock falling down into Mars and making holes. In some of those craters, there are these strange black splotches. At least some of those splotches, on closer inspection by Mariner 9 cameras, turn out to be vast sand dune fields, another indication of wind-blown sand and dust on Mars. Here is an astounding feature which no one expected on Mars, an enormous rift valley, almost 3,000 miles long, comparable to the largest such feature on the Earth, a sign of great geological activity.
In this model, the flat surface of a large Martian plateau is cut by the Great Rift. A smooth sloping ravine drops abruptly to the bottom of the canyon 4 miles below. The small peaks on the canyon floor were once part of the plateau surface. Today, this great fracture in the crust of Mars is 75 miles across. The original fault has been widened and shaped by various forms of erosion. Great landslides are triggered by quakes that shake the crustal rocks. Wind-blown dust strips the receding canyon walls. Some side canyons may have been deepened by running water. Melting of underground ice, followed by slumping of walls, further erodes the great fault. This Rift Valley, of which we have seen only a small part, is so huge that it would span the United States.
Looking now, baby, see them rockets in the sky. Somewhere there's someone steady staring upwards as they die. Some folks is frowning, doubting, but we never play around. Spike a holy ball of fire from the heavens to the ground. Yes, we're looking for a crowd. Blizzard, rockets in the sky. Yes, we're looking for a crowd. Blizzard, lit up like the 4th of July. Beautiful and deadly like a devil femme fatale. Got people across our nation screaming, can you hear us now? No stranger propaganda, we're all suckers for a show. Grab a weapon at the door and leave behind your moral code. Yes, we're looking for a crowd. Blizzard, rockets in the sky. Yes, we're looking for a crowd. Blizzard, lit up like the 4th of July. Yes, the waves have all crested and we're all in a daze. We're all down in the valley, just living through the haze. Seems history is ended, time to cash in those checks, but you ain't seen nothing yet. The fuse has just been lit. It's a road runner, air grabber, out on a cruise. It's a working man, a rich runner, yeah, it's burning up the blue. She my kissing cousin, wild-hearted, but her aim is true. Top up window, flash, my baby's howling at the moon. Yes, we're looking for a crowd. Blizzard, lit up like the 4th of July. Looking down, baby, see the lights up in the sky. Lights up in the sky. Looking down, baby, see the rockets in the sky.